All right, in this video we're going to talk about how to develop a loft so we can set up our wind turbine blade. And if you can see what we have here, starting down here at the bottom, this is the hub piece of the wind turbine blade. This is the hub that you can start out with. You can open that from the TechEd server. When you get that hub, then you're going to start working on the design of your blade. And the design of your blade comes a lot into the twist that you are going to apply to the airfoil and the design of the airfoil that's going to come from your own ideas. And really what we're going to set up today is to show you how to work that loft with some ideas of the true wind, the parent wind concept. So given that this is what we're looking to accomplish, I'm going to go ahead and open up. This is the start file. This is coming from the TechEd server. This is the joint hub. Once you open this up, I want you to save this to your TechEd server space because you will not be able to save back to the class resources folder. So to go ahead and start the design process, I'm going to go ahead and start a 2D sketch, and I'll place that 2D sketch on the face of the hub. Once we do this, I need to set up the center where the center line would be for this hub. So I'm going to wait till I get my midpoint to pop up there, and then I'm going to draw across the part. So now this is going to be what would be the center axis of the blade system here on the hub, and set it up so that I'll go ahead and draw an arrow here quickly. The true wind is going to be running into our hub and our blade in this angle. All right, so our true wind is coming to the blade in this way, and then the apparent wind is going to be attacking the blade in this angle, and then the rotation axis is going to be running vertically here. So what I'm going to want to do is start setting up some angle information here, not getting into any calculation, but what I'm going to do is I'm going to set up from my center point on my horizontal. I'm going to go ahead and set up an angle. This angle is going to then represent the apparent wind and how that is going to attack my blade. So we'll go ahead and set this up, and I'm just going to then say, okay, let's say it's 10 that the apparent wind is, or if I wanted to say let's go with 15, we could go ahead and change this to change what that angle would be. This is something that we'll discuss a little bit later, but to set this loft idea up. So we'll set this up as this is my angle of attack for my apparent wind, and then I'm going to go ahead and start working in the airfoil itself. So if my apparent wind is coming at my blade at about 15 degrees, then I really want to set up my angle of attack for my airfoil at a slightly steeper angle, with the idea that an airplane wing, or a wing in general, has a slight elevation to it, so that you have the idea of high pressure and low pressure working around. So with that set up, I'll go ahead and I'm going to set this up to say that we're going to work off at about another 10-degree angle from what would be the apparent wind angle. So this will be the angle that I start working with to my airfoil. From this point, I'll go ahead and grab my spline control vertex tool. After I pull down my line tool, you'll see the spline pops up, and we'll go ahead and grab that. And now I'm just going to go ahead and really rough in a pretty quick, easy airfoil here that is going to work across. Hit my green check there, and then I'm going to go ahead and use the extend tool to extend to the end of my spline. So this is what's going to be my airfoil rough shape here on my hub. So with setting that up, then I can go ahead and start working out some other aspects. So we'll go ahead and I'll hit finish sketch. And what I'm going to immediately do is I just want to make sure that I have a closed loop. So I'll just grab the extrude tool and select inside, and I do. I can certainly extrude this. That means it's certainly eligible then for a loft operation. So next thing I need to do is I need to get another sketch, and I need to get that sketch based off of the location from the hub. So I'm going to have to pull this out here. So I'm going to grab my work planes, and I'm just going to grab offset from plane. I will then set up a work plane by mousing over the surface. I will left click, hold, and just move my mouse. As I drag my mouse out, you can see work plane being lifted away from the face. So this is going to come into how large of a wing I want to set up. This is going to come into how large of a system we have set up on the table to spin. So I'm just going to go ahead and set this up and just say 9 inches for the sake of design here. Not sure what the actual measurement should be, but I'm just going to set up 9. You guys can check that measurement before you design. And I'll go ahead and do a start 2D sketch, and I'm going to place it on that work plane. They directly overlap each other, which is great because all I really want to set up now is I want to set up the twist. So we're looking at a twist from root all the way up to the tip of the blade, somewhere in about 10 to 20 degrees. So I'm going to go pretty extreme, where I will go ahead and need to project the geometry from the first sketch, and I'm going to go ahead and project that geometry so that my center is the same, and then I can find center. And again, I'm going to draw a line, and then I'm going to utilize project geometry for the last angle, and I will then go ahead and dimension from the bottom of the airfoil on the base to the airfoil angle that's going to be set out at the tip. And I'll go with that 20 degrees and set that up. Oh, come on, it's not taking it for some reason. There we go. So now we're set up here at 20 degrees. So I can start working out the new airfoil with a twist from the base to the root, or to the tip. So now I can go ahead and grab my line tool, and again I'm going to start working the spline. I'm actually going to say let's just, this was sort of fictitious how far I went out here, but I'm just going to use the tip, and I'm going to make this a whole lot wider of an airfoil, but I'm probably going to go ahead and let's just make this a little different in that this airfoil is going to be very, very thin. I want to see if I thin it out at the end, if that's going to make a difference when we start testing. So we'll set this up. I'll set up an extension and extend that line with the extend tool out to the tip of that spline. So with that set up, I should be able to go ahead and hit finish sketch. And now we should be able to start working with my loft tool. All right, so zoom in, zoom out here. We'll go ahead and take a look over here. Coming across from extrude to revolve, here's our loft tool. We'll go ahead and select the loft tool. And what we want to do is select the first sketch that we created. And you can see it highlights in there. The dark blue is what will get extruded. And then we're going to come out and then select the second sketch. And you can see as I rotate that this is really setting up that twist in my wing, and I can really get an idea of what this is going to look like. So I'll go ahead and hit OK, and then you can see that I have then created this loft from the first airfoil out to the second airfoil with a twist. Now if I decided that I want to go back in and edit these two foils, I can get back into the sketch. And with the spline, I could actually go ahead and just start stretching and changing and pulling. So the more spline control points that you add, the more flexibility you have to start manipulating that particular part. Then when you hit update or hit OK, it's going to go ahead and update and then blend these together. So this is something where this is your design. This is where I want you to come up with ideas on what you think is going to allow us the most amount of lift on our turbine. One of the things that we can do to add some strength is to go ahead and add a fillet down here along this front edge. By adding a fillet down here to the front edge along the base here, it's going to add strength and stability to the system and to this blade. By doing that, any type of vibration that is going to occur can be mitigated from actually turning into a crack or a break in our 3D printed part. So something I'd highly recommend doing there is to add a fillet to the foil at the joint hub. And then we're ready to go ahead and take this thing out to as an STL and print and be able to start testing our blades. So hopefully this helps with a loft for our windmill project.